Hello friends, so in today's lecture we are going to be discussing surds. So what then would surds be? Surds are irrational numbers which are in the form of roots. I repeat, surds are irrational numbers which are in the form of roots. Examples would be root 2, root 3, root 5, and root 7. Root 7. These are some few examples of surds. Now, how can we evaluate problems involving surds? How can we solve problems involving surds? In evaluating surds, the first thing we are going to be looking at would be the simplification of surds. Simplification of surds. How do we go about this whole piece? How do we handle this whole piece? The simplification of surds. Now, simplification of surds. Now, in simplifying surds, now there are various approaches we can take. The very first of them would be this. Let's call it Roman figure 1. Now, suppose we are given the root of AB, the root of AB. What this would give us is root A times root B. This is what we are going to have in this form. Root A times root B, such that if we are given real numbers such as the root now of 16 times 5, 16 times 5, now this would be root 16 times root now 5, root 16 times root 5. What we are going to have in the aftermath, notice now that the root of 16 gives us 4, and the root of 5 would be an irrational number, so we leave it just the way it is in accordance with the principles of surds. So in the aftermath, our final answer would be 4 root 5. 4 root 5. This is what we're going to have in this form. Also, we could be given root 25, roots now 25 times 3. We can evaluate this in the same manner, and we're going to have the root of 25, the roots now of 25 times the roots of 3 times the root of 3. Notice now that the root of 25 would give us 5, and the roots of 3 would be an irrational number, and in this form we leave it just the way it is, and our final answer in this form would be 5 roots 3. 5 roots 3. Very true, very true. This is one of the ways we can evaluate surds when simplifying them. This is one of the ways we can simplify surds. Let's look at another classic way we can simplify surds. Let's look at another method by which we can simplify surds. Now, let's call this Roman figure 2. Now, if we are given the root now of A over B, the root now of A over B, what this would give us is root A divided by root B. This is what we are going to have in this form, such that an example now, you could be asked to evaluate the root of 36 now, root of 36 divided by 4, the root of 36 divided by 4. What you do in this form now is that you give each of them an individual root, right? So you have root 36 now divided by root 4, and notice now that the root of 36 would give us 6, and the root of 4 will give us 2, and in the aftermath, right, in the aftermath, our final answer 2 into 2 here is 1, and 2 into 6 here will be 3. So our final answer would be 3. Now, the final way by which we can evaluate surds as per simplifying them now would be in this form. If we are given roots now, a times root a times root a, the answer would always give us a. What happens here is that root a times root a times root a gives us root a square, and the square cancels the square root. In the aftermath we have a. So classic examples of this would be when you are given the root of 5 now, root 5 times root 5 times root 5, and what we have in this form would be 5. Let's play with some classic examples now that will help us understand the concepts of simplifications of surds better. Now, in playing with one or two classic examples now, we could be asked to simplify root 27, the root of 27. Now, in simplifying this now, we need to find two numbers, right? Two numbers whose product will give us 27, and one of these numbers must be a perfect square. A perfect square would be a number which can be gotten by the multiplication of two similar numbers. For example, 2 times 2 gives us 4, so 4 would be a perfect square. 4 times 4 gives us 16, so 16 would be a perfect square. 9 times 9 gives us 81, so 81 now would be a perfect square. How true? Very true. Now, for 27 now, two numbers we can multiply that would give us 27 would be 9 and 3. 9 and 3. So we're going to have the roots now of 9 times 3. The root of 9 times 3. Now, just as we've been doing previously now, we can separate this now, and we have root 9 times root 3. Root 9 times root 3. Now, notice now that the root of 9, now the square root of 9 would give us 3. And the root of 3, the square root of 3, now notice now that that would give us an irrational number. So according to the principles that govern the operations now of surds, we have to write root 3 the exact same way it is. And in the aftermath, right, our final answer becomes 3 root 3. How true? Very true. Let's take another classic example that will help us understand the concept of surds better. Now, we could be asked now, right? We could be asked to simplify root 75. Root 75. And the same rules apply, right? In simplifying this, we need to find two numbers, right, whose product gives us 75. And one of these numbers must be a perfect square. It turns out now that 75 can be gotten by multiplying 25 times 3. 25 times 3. Now we can separate these and we can have the root of 25 times the roots of 3 times the root of 3. Now notice now that the root of 25 gives us 5, right? Gives us 5. Multiplied by root 3, we have to write root 3 just the same way it is. Why? Because the root of 3 would give us an irrational number, so we have to put it just the way it is in accordance to the principles that govern the operations of surds. Now, in the aftermath, our final answer gives us 5 root 3. 5 root 3. How true? Very true. Very true. Now, let's take another example that will help us understand better. Now, assuming we are told to simplify root 80, right? Simplify root 80. We're still going to find two numbers whose product would give us 80, and one of them must be a perfect square. So two numbers whose product would give us 80 are 16 and 5. So what we have is the root now of 16 times 5. Root 16 times 5. So in the aftermath we have root 16. I told you we can separate them, right? Times root 5 times root 5. Now root 16 gives us 4, and root 5 now. Root 5 is an irrational number, so according to the laws that govern the operations of surds, we write it just the same way it is. So our final answer gives us 4 root 5. 4 root 5. This would be our final answer. Let's take one more example. Now, suppose we are asked to simplify root 320. Root 320. Now, how do we go about this whole piece? The same rules apply, right? We're going to find two numbers now whose product give us 320, and one of them must be a perfect square. So two numbers whose product gives us 320 are 64 and 5. So what we have now would be root 64 times 5. So we can separate that, and we have root 64 times root 5. Root 5. And in the aftermath, right, notice now that the root of 64 will give us 8. Root 64 gives us 8. And root 5 now, being an irrational number, we write it the same way it is. So this gives us our final answer as 8 root 5. Thank you so much for watching. Now in the next video, right, we're going to be looking at addition and subtraction of surds. In subsequent videos, we're also going to be looking at the multiplication of surds and the rationalization of surds and many other operations of surds. Thank you so much for watching. See you in the next video.